As we mentioned before, we got two things going on when we're talking about vapor-liquid equilibrium, right? Rate of vaporization, so we got liquids going to gas, and then rate of condensation, gases going to liquids, okay? Only two things we're talking about here. So volume is a huge impactful thing for our equilibrium. Let's talk about it. So right now, at 8, we have the dynamic equilibrium, right? So we at equilibrium right now, right? Remind everybody, equilibrium, right, is when our rates are the same. So right now, this is telling me in this chamber, right now, we got our liquids and our gas particles going on right here. And this is telling me, because we're in dynamic equilibrium, our rate of vaporization, okay, is going to be the same of our rate of condensation. Look at all these Asians. What's that, Bill? I'm just a Bill. It reminds me of that type of stuff. All these Asians and condensation, evaporation, the rhythm nation. I don't know. Okay, so now this is letting me know we reached that equilibrium point. All right, as many gas molecules that are turning to liquids, condensation, there's as many liquid molecules turning to gases, vaporization. Okay, so what happens now if we start playing with the volume? Okay, you already know this is chemistry, some experimentation, another Asian, right, is going on here. So if we play with the volume, say we're going to increase our volume. Okay, so bam, just increase the volume. What we're going to see here is that the pressure is going to fall. Okay, the pressure falls. The pressure is falling, right, because we have more volume. We'll talk more about this in equilibrium later on as far as the why, but we just need to understand that the volume, if it increased, the pressure fell down. Okay, it falls. Now, what we're going to see here, right, now that pressure is decreased, right, what happens to our processes? The rate of vaporization is now going to be faster than the rate of condensation. And that's because we're changing the volume, okay? You change the volume, you're going to change something. So now that it has a bigger vaporization, right, the volume is bigger. And what's going to happen is that, okay, now, right, we got more room for my gas molecules to move around. So because of this, right, we're going to see more liquid molecules start to be converted to gas molecules. Because we know, right, gases like to take up the space. Okay, and the liquid, it can't take up this space. It can only do so much. The gases, though, you know, they independent. They can take up this space. And that's exactly what they're going to do right now. But, let's say we flip it again. And the volume, let's say we're going to decrease the volume instead of increasing. What happens to that pressure? Well, the pressure is going to rise, right? You shrink down, you get small in there. It's not as much room. The pressure gets bigger. And during this process of decreasing the volume, okay, our pressure is rising. So if our pressure is rising, that means that our gas will condense, right? If your gas condenses, that means that it's going from a gas to a liquid. So during this point, right, the rates of vaporization is going to be smaller than our rate of condensation. That's because it's not as much volume. And you know, gases need their volume. Okay, so we see this is the reason why they're spending here. However, liquids, they thrive. They thrive right now. So, right, this is very ideal for condensation to increase.